Humanoid robots aren't just improving anymore, they're getting too real. Every week, the line between science fiction and reality gets thinner, and this week might be the biggest jump yet. Unitree just unveiled its new H2 humanoid, strong enough to go head-to-head with the G1 in a full combat demo. Elon Musk confirmed that Optimus Gen 3 can now run, and the new Gen 2.5 hand pushes it even closer to real-world usefulness. A Chinese company has stepped in with a jaw-dropping reveal, a robot designed as a real-life Terminator. Hey guys, Alfie here. Welcome to AI Nexus. This week, AI robots push the limits again, and some of these updates feel almost unreal. Alright, something big just happened in robotics. Unitree just dropped a new demo of its H2 humanoid, and this time, it's not just walking or lifting boxes. The H2 is fighting the G1, and then two H2s go head-to-head in a full robot versus robot sparring test, and honestly, it reveals more about Unitree's engineering than any polished promo clip. In the H2 versus G1 sequence, what stands out isn't the aggression, it's the control. Every time the H2 delivers a strike, you can see how the force travels through its legs as the ankles and hips instantly adjust to keep balance. This isn't choreographed motion, it's real-time force redistribution across multiple joints. Even the lighter G1 tries to stabilize before getting overwhelmed, showing how each robot is designed for a different purpose. G1 for lightweight research, H2 for industrial-grade force. One key moment. The H2 lands a knee strike that actually lifts the G1 off the ground. That tells you everything about the H2's torque and frame strength. And the impressive part is how steady it remains afterward. The human interaction segment also hints at high-frequency balance control, with the H2 making tiny ankle corrections after each push. But the real highlight is the H2 versus H2 fight. Two robots generating force at the same time creates a perfect stress test, and both recover from punches and kicks with surprisingly smooth posture correction. The H2 stands nearly 6 feet tall, weighs around 70 kilograms, has 31 joints, high-torque motors, and a hot-swappable battery, clearly built for industrial environments, not flashy combat. Overall, this demo shows the H2 moving beyond lab motions and into real-world force handling. It's a big step toward practical humanoid robots. Now, while Unitree is pushing the limits of physical strength and balance, Tesla is quietly evolving the other side of humanoid robotics: precision, stability, and long-term utility. Tesla just dropped one of its most important updates yet. Optimus can now run. And while that single clip is short, it reveals real progress in Tesla's locomotion system. The run isn't about raw speed, it's about stability. Optimus maintains a centered posture, places its feet deliberately, and keeps the upper body steady without the exaggerated arm swings we saw earlier this year. The smoother gait suggests Tesla's control loops. The software coordinating hips, knees, ankles, and torso are becoming more synchronized. For a robot built from scratch in just a few years, this level of refinement matters. But the clip also raises questions. Tesla didn't show how Optimus transitions into or out of the run, which are often the hardest parts. No turns, no uneven terrain, no sudden stops. All areas that will determine how reliable this running system truly is. Still, compared to earlier demos like Tesla's kung fu drills and weight-shifting routines, this running form shows a clear evolution towards stronger torque control and better balance. The second major update, the new Gen 2.5 hand, might actually be the bigger deal. Running makes a robot look impressive, but hands decide whether a robot can actually work in the real world. Tesla's new hand adds more degrees of freedom, improved tendon routing, softer silicone material, and better tactile sensors in the fingertips. Each finger now moves with a smoother, more natural curve, and the redesigned thumb supports more advanced grips. This directly addresses the limitations we saw in earlier Optimus demos: folding clothes, sorting objects, simple food service tasks. Those attempts were promising but inconsistent. With better sensing and finger geometry, Optimus can now detect slip, apply more precise pressure, and hold irregular objects more confidently. More joint freedom means it can perform manipulation tasks like twisting, pinching, and rotating items in its palm, all essential for real household or factory workflows. Taken together, the running demo and the Gen 2.5 hand show the same pattern: Tesla is quietly strengthening the core systems Optimus needs for real utility, mobility, and manipulation. The flashy milestone is the running, but the meaningful milestone is the hand. Both updates push Optimus closer to becoming a practical, general-purpose humanoid rather than a staged demo machine. And while Tesla continues refining Optimus for practical work, another company is taking a radically different approach. Engine AI has finally revealed its T800 humanoid robot, and it's one of the most ambitious designs to come out of China's rapidly accelerating robotics scene. While companies like Boston Dynamics and Unitree push the field forward with agility and low-cost experimentation, the T800 enters a different category entirely. A humanoid built around power, stability, and near-human movement. The design instantly stands out. Engine AI openly borrows the T800 name from the Terminator, not as a gimmick, but as a guiding philosophy. Strong structure, balanced proportions, and motion that looks controlled rather than robotic. Aviation-grade aluminum keeps the frame lightweight but rigid, and the straight-leg walking approach is a bold engineering choice. Most humanoids rely on bent-knee walking to stay stable. The T800 doesn't. Every micro-adjustment in the hips and ankles is calculated in real time, giving the robot a more human-like gait. Underneath that movement is serious hardware. Each joint delivers up to 450 Newton-meters of torque, enough for fast pivots, strong strikes, and absorbing impacts. But high torque usually creates heat, forcing robots to slow down. Engine AI solves this with active cooling built directly into the leg joints, letting the T800 run high-intensity motions for hours without thermal throttling. A solid-state lithium battery backs it with long, safe endurance. This engineering-first mindset is why the T800 is heading straight into the Mecha King humanoid fighting competition on December 24th. Human operators will control strategy while the robot executes the physical moves, turning stress testing into a public benchmark. Engine AI isn't chasing spectacle. It wants to expose weaknesses early and refine the hardware under pressure. With China's robotics ecosystem accelerating and Engine AI moving at an unusually fast development pace, the T800 represents a major step forward. Whether it can challenge giants like Boston Dynamics is still unclear, but one thing is obvious. This robot isn't just inspired by the Terminator, it's engineered for real-world intensity. And speaking of movement, another company just showed a very different kind of running performance. Figure AI just entered the running war, and their new Figure 03 clip might be the most natural humanoid run we've seen yet. While many robots can jog forward in a straight line, Figure 03 shows something far harder: coordinated, instinctive motion. The robot moves with a springy, elastic gait, heel-to-toe foot rolls, relaxed arm swings, and even a small flight phase where both feet leave the ground. But the standout moment is the 180-degree pivot. Figure 03 plants its foot, rotates its hips, swings its arms for counterbalance, and continues running without hesitation. That kind of turn requires rapid whole-body coordination, something robots usually struggle with. The motion doesn't look scripted, it looks learned. That realism comes from Figure's LimX AI control stack, which blends vision, proprioception, and foot sensor data. Behind the scenes, the robot trains through millions of virtual sprints, slips, and recoveries, compressing years of human learning into hours. A lighter chassis also gives Figure 03 a bouncier, more athletic gait. When both feet lift off the ground, even briefly, it qualifies as true running, and Figure's execution places it among the most human-like runners in any commercial team today. And while the humanoid race is heating up, another corner of robotics took a massive leap this week, this time from the world of animation. Disney just brought Olaf from Frozen to life as a real walking, talking robot. This isn't classic theme park animatronics. Olaf walks on his own, interacts with guests, and you can even remove and reattach his carrot nose and twig arms just like in the movie. The secret is reinforcement learning. Instead of programmers hand animating every move, Olaf trains in simulation, practicing thousands of virtual steps and gestures until the motion looks natural. Disney worked with NVIDIA and Google DeepMind to create a system called Newton, which can cram 10,000 hours of robot training into a few days. What makes Olaf especially difficult is his design. A soft, deforming snow body, fully animated eyes and mouth, a detachable nose, and live conversation abilities, not pre-recorded lines. To interact with guests, Olaf uses stereoscopic cameras to detect people, gestures, and movements. If you wave, he waves back. The motion is AI-driven, while a Disney cast member controls dialogue and character behavior. Olaf debuts at Disneyland Paris on March 29, 2026, with limited appearances at Hong Kong Disneyland. And the big thing is this: Olaf isn't a tech demo. He's entering daily park operations. For the first time, a movie character isn't just animated on a screen. He's walking around in the real world. Listen, robots just took another massive leap forward, and you need to see this. LimX Dynamics dropped something absolutely wild this week. Their humanoid robot Olaf walked across an actual construction site like it was nothing. We're talking loose sand, scattered rocks, wooden planks, and debris piles everywhere. This is terrain that would make most of us stop and watch our step. But Olaf? It just powered through. Here's where it gets crazy. This robot has 31 movable joints working together in real time. Every single joint adjusts continuously to keep the machine balanced and moving forward. It's called whole body dynamic control, and it basically means every part of the robot talks to every other part instantly. Your body does this naturally when you walk on uneven ground. Olaf can now perform that same natural moment-to-moment balancing act we normally take for granted. The breakthrough came from something engineers call randomized training. LimX threw Olaf into thousands of different virtual scenarios before letting it loose in the real world. LimX trained Olaf to handle the unexpected, to recover when the ground shifts beneath it. That's the Sim 2 real gap right there, getting a robot to perform in messy reality the same way it performs in perfect simulations. And Olaf crushed it. Why does this matter? Because confident, stable walking is the core ability that unlocks every other real-world job. Once a robot can reliably move through chaotic environments, it can start doing real work, carrying materials, inspecting structures, assisting human workers on dangerous job sites. We're watching embodied AI move from controlled factory floors into the actual world where things get unpredictable fast. But here's where the competition gets absolutely brutal. Agility Robotics just announced their humanoid Digit moved over 100,000 totes in live commercial operations. Not in a lab, not in a demo, in an actual GXO logistics warehouse with human workers and real business operations running. And the timing? Chef's kiss. Just days before this announcement, Figure AI's CEO predicted Agility would file for bankruptcy within 12 months. Then Figure reported that the Figure robot managed over 90,000 part-handling operations at BMW's facility. One day later, Agility drops this milestone. That's how cutthroat this industry has become. Everyone's racing to prove their robot actually works in the real world. Digit walks on 2 legs and uses 2 arms just like a human. That means it doesn't need specialized conveyor systems or custom infrastructure. It works in spaces designed for people. It navigates stairs and obstacles that completely block the paths that wheeled robots can't navigate at all. Handling 100,000 totes makes one thing clear. Digit can sustain full shift performance. This isn't experimental anymore. Digit is providing actual value in warehouse operations, and GXO Logistics operates hundreds of facilities globally. If this scales, we're looking at a fundamental shift in how warehouses function. Now here's the plot twist that should worry Western robotics companies. Chang'an Automobile, one of China's massive state-owned car makers, just established a dedicated robotics company. Chang'an Automobile is joining the humanoid robot race, and Chang'an is bringing serious advantages. Automakers have years of experience building complex machines, and companies like Chang'an already have strong supply chains for motors and sensors, the same parts needed to build humanoid robots. Tesla showed everyone the playbook. They positioned themselves as an AI robotics company, not just a car maker. Tesla's Optimus robot runs parallel to Tesla's vehicle business, sharing vision systems and manufacturing processes. XPeng followed the same path. Now Chang'an's jumping in with state backing and long-term investment horizons. This convergence makes perfect sense for companies like Tesla, XPeng, and Chang'an. Building electric vehicles and building robots require solving the same problems: real-time sensor processing, path planning in dynamic environments, electric motor control, battery management. A factory that builds EVs already has the infrastructure to manufacture robots. As more automotive giants establish robotics divisions, the industry definitions are blurring fast. Companies that made cars are now calling themselves AI robotics companies. And when you've got state-owned enterprises in China with unlimited timelines and massive resources entering the game, the race just got a whole lot more intense. The future's arriving faster than anyone expected. Here's the thing about humanoid robots. Just when you think the industry can't surprise you anymore, 4 completely different machines show up and flip the script. XPeng's Iron moves with so much human presence that people still argue whether there's someone inside it. 1X's Neo isn't just the first humanoid you can actually pre-order. It's designed to feel calm, safe, and almost invisible inside a normal home. Figure 03 is out here proving real factory precision at BMW while also handling everyday chores like folding shirts and loading dishwashers. And Tesla's Optimus Gen 3 is quietly building the strongest AI brain in robotics. 4 robots, 4 philosophies, and all of them are redefining what human-like really means. When XPeng unveiled Iron on stage in Guangzhou, the internet practically shut down. Viewers watching the live stream were convinced it had to be a person wearing a suit. The walk was too fluid, the balance was too natural. Even the hip movement looked like a professional runway model. It created so much confusion that XPeng's CEO had to step onto the stage, remove the outer panels, and reveal the motors and mechanics inside, just to prove the robot was real. That's the level of human-like motion XPeng achieved. Iron stands 5'8", weighs 154 pounds, and walks at around 4.5 miles per hour. XPeng trained its gait using thousands of hours of real human walking data, and the result doesn't just mimic human motion, it feels like someone is actually inside that frame. Iron also comes in both a male and female version, created by adding synthetic padding under the soft outer shell. This design choice isn't just about looks. XPeng believes that human-like silhouettes build trust in environments like showrooms, factory tours, and eventually homes. But while Iron focuses on natural movement and human presence, Neo from 1X Technologies takes a completely different approach. Neo isn't about sprinting or breaking speed records. Instead, Neo's strength is smooth, controlled, human-like walking and a design that feels safe in everyday spaces. The outer body uses soft fabric materials, giving Neo a friendly appearance that blends into homes, offices, and retail stores. At just 66 pounds, it's the lightest humanoid robot here, and one of the quietest, designed to move without harsh mechanical noise. Every joint is covered, pinch-proof, and shaped for safety. The philosophy is simple: build a robot that can move naturally around children, pets, and furniture without feeling intimidating. Neo doesn't aim to look human, it aims to feel trustworthy. Then comes Figure 03, the precision specialist. Figure isn't chasing lifelike walking or soft, friendly aesthetics. The company's focus is intelligence, balance, and fine motor control. Figure 03 uses palm-mounted cameras that give it a close-up view of anything it touches. These cameras allow the robot to adjust grip, angle, and motion with remarkable accuracy. Figure 03 also uses wireless foot-based charging. Step onto a pad, and it pulls power directly through its feet. Most importantly, Figure 03 is already confirmed for BMW's assembly line. This isn't a lab demo. BMW has committed to real deployment, and that validates Figure's direction more than any marketing video. Now let's talk about Tesla Optimus, the AI titan of this group. Optimus doesn't walk like Iron yet, and it doesn't use soft fabric like Neo or Figure 03. Tesla chose a hard shell because Optimus is engineered for practicality and durability. But what Optimus does have is the strongest AI foundation here. By far, Tesla didn't build a new intelligence system for Optimus. The robot uses the same neural architecture as full self-driving, a multimodal model capable of processing vision, language, planning, and movement together. That gives Optimus an enormous advantage. Years of driving data, simulation, and training pipelines are reused for robotics. Optimus Gen 2 already walks at 5 miles per hour and navigates Tesla factories autonomously. And Optimus isn't limited to factory floors anymore. It's been spotted in Tesla's diner, serving popcorn and performing basic interactions with customers. The upcoming Gen 3 is expected around early 2026, and Elon Musk has openly targeted a mass production price between $20,000 and $25,000, with a dedicated production line aiming for 1 million units per year. Comment below. Do you think Tesla can hit this 2026 timeline, or will it slip again? But the big question is this: what can these robots actually do right now? Because online demos can look perfect, even when they aren't. A lot of autonomous videos are heavily guided or curated, so here's the grounded reality. Neo is the robot closest to real home usage. Not because it's the most advanced, but because it's the only one with actual consumer pre-orders. 1X Technologies opened reservations in October 2025, with deliveries planned for 2026 in the US and 2027 internationally. Neo can perform tasks like folding laundry, opening doors, organizing rooms, watering plants, fetching objects, and setting tables. But here's the important part. Neo learns through expert mode. When Neo doesn't know how to do something, a human operator controls it through a VR system. Neo watches, imitates, and gradually becomes autonomous. It's not fully independent yet, but the company is transparent about how the training works. Figure 03 performs similar household tasks, loading dishwashers, folding shirts, picking up clutter, but it also handles factory-level tasks with accuracy. Public demos look autonomous, but Figure has confirmed that teleoperators are still involved behind the scenes for data collection and refinement. This isn't a flaw, it's the normal process of training humanoids. Don't blink. Hit subscribe so you never miss what's coming next. Tesla Optimus is currently used internally inside Tesla facilities. It sorts parts, moves components, assists in manufacturing workflows, and navigates hallways without assistance. But because Tesla never allows external validation, its true capabilities outside Tesla environments remain unknown. XPeng Iron is still in its early demo phase. It currently works in XPeng showrooms, guiding customers and presenting features of XPeng vehicles. Iron has also been seen inside XPeng's factory, where engineers are testing its ability to perform basic support tasks. Mass production is targeted for late 2026, but no consumer pre-orders are open yet. Now here's the part most people don't realize. Out of all 4 robots, only Neo can be pre-ordered today. A fully refundable $200 deposit secures your reservation. The full price is $20,000 with a 3-year warranty, or you can subscribe for $499 per month with a 6-month minimum. No other humanoid, not Tesla, not Figure, not XPeng, has opened consumer reservations. Share your thoughts. Would you pre-order Neo now or wait for Tesla, XPeng, or Figure? Figure 03 isn't offering consumer pre-orders. Their focus is commercial clients. Tesla Optimus doesn't have a pre-order page, but it does have a target price and a clear timeline. 20,000 to 25,000 mass production target. Prototype manufacturing line in 2026. Goal 1 million units per year. XPeng Iron is aiming for a similar price range, $15,000 to $20,000. But again, reservations aren't open. Now let's talk about intelligence, because movement is only half of what makes a humanoid robot useful. Tesla Optimus has the most mature AI system thanks to years of full self-driving training. The neural network understands depth, trajectories, object motion, spatial reasoning, and Tesla's massive simulation pipeline gives Optimus a huge data advantage. If Tesla stays consistent, Optimus could become the most capable general-purpose robot of the group. Figure 03 uses LimX AI, a model built specifically for humanoids. LimX AI lets Figure 03 see more clearly, react faster, and understand its environment better than Figure 02. The improvements in field of view, responsiveness, and motion planning give Figure 03 a level of precision that BMW was confident enough to test in real workflows. Neo uses Redwood AI along with a built-in language model for communication. It also supports fleet learning. Every NEO learns from every other NEO. But the robot still depends heavily on expert mode for new tasks. XPeng Iron has strong compute power using its 3 Turing AI chips. XPeng's VT brain combines vision language action models for spatial awareness. It's a capable system, but XPeng is newer to humanoid robotics than Tesla or Figure, so the software still has room to grow. Now let's talk hand skills, because this is where the biggest differences appear. Figure 03 leads in precision thanks to its palm-mounted cameras and advanced tactile control. Neo uses tendon-driven manipulation that's soft and gentle, great for home tasks. Optimus Gen 3 is expected to deliver some of the most advanced hands ever shipped once production begins. XPeng Iron uses soft skin-covered hands, but XPeng hasn't released enough detailed demos to judge precision. Finally, design philosophy. This is where the biggest visual differences emerge. XPeng Iron leans into human aesthetics. Wider hips, soft outer shell, and gendered silhouettes created through synthetic padding. XPeng believes human-like presence boosts trust and comfort. Neo, Figure 03, and Optimus take a functional design approach, neutral, clean, and non-gendered, using fabric or hard shells depending on their purpose. Neo and Figure use soft materials to appear friendly and safe. Optimus uses a durable hard shell optimized for factory environments. So who wins? If you want a robot now, Neo wins. If you want the strongest AI, Optimus wins. If you want cutting-edge precision, Figure 03 wins. If you want human-like movements, Iron wins. There's no single champion, because each robot represents a different vision of the future. In 10 years, owning a humanoid robot will feel as normal as owning a smartphone. The real question isn't whether you'll buy one, it's which one and when. Iron is the robot that looks human. Neo is the robot you can reserve today. Figure 03 is the robot built for fine motor mastery. Optimus is the robot with a world-class AI brain. 4 robots, 4 philosophies. And together, they're writing the next chapter of human-robot coexistence. The robot revolution isn't coming, it's already here, and it's stepping into your living room in 2026.